where it began. I can't begin to know it, but then I know it's going strong. Hands, touching hands, reaching out, touching me, touching you. Sweet Caroline, good times never seem so good. I've been inclined to believe there never would, but now Go, Daddy!
Hello everybody, welcome to this week's edition of Video Notes for Mr. Flugum's General Chemistry class. That's right, I said this was for Gen Chem, not AP. And these notes, you guys, are going to go on page number 39 in your science notebook. Okay, and let's go ahead and get it started. We're talking about covalent compounds today. Okay, so covalent compounds. Here's the deal. We have a covalent bond, right? So this is a bond between atoms when we're sharing electrons. So far we've talked about ionic compounds where electrons are given and taken. Now we're going to start talking about sharing. So an example is water. Water is a covalent compound. Okay? And you can see here, right? Hydrogen shares its lone electron, which is the black dots, right? And oxygen shares its unpaired electrons, which are the white dots. Okay? And what happens is this, right? There isn't a complete give or take by either atom. That electron is shared between them. Now, what makes ionic and covalent compounds different? Well, there's a few things, right? The biggest thing is this, right? How do we tell the difference? Well, ionic compounds contain a metal element, okay? So, if it's got a metal element in it, it is ionic. Covalent compounds do not contain a metal element. Okay, that's important. So for example, NaCl, right, salt, okay, Na is a metal, that makes it an ionic compound. This one here, P2O5, that's phosphorus and oxygen, right? Neither one's a metal, therefore that is a covalent compound. So here's a bit of a quick comparison for you between ionic and covalent compounds, all right? So big thing is this, right? Ionic compounds, okay, give and take electrons, right? And they're stuck together by opposite charges. That's what makes the atoms stick together, right? The plus and the minus, okay? And we know this because they contain a metal element. Remember, there is one exception when I say most of the time. The one exception is this, when we have ammonium, right? NH4 plus. That makes it ionic, even though there isn't a metal. Okay, covalent compounds, on the other hand, share electrons, right? And what makes them stick together is those shared electrons. You know, the atoms can't be too far apart if they're going to share that electron, right? So they have to stay in close proximity. And they also do not contain metal elements. Okay, folks, so when we name these compounds, we're going to just work on what are called binary covalent compounds. So binary means we only have two elements, okay? Might have carbon and oxygen, or chlorine and phosphorus, or something like that. Okay? So when we do this, we're going to use prefixes. Okay? Those prefixes help us describe the number of atoms present. And I'll explain why in just a second. Now remember, a prefix is a part of a word that goes on the beginning, goes on the front part, and it changes the meaning of that word. In this case, it tells you how many there are. Here are the prefixes for covalent compounds. Okay, the weirdest one, by the way, I need you to write these down. You need to have these in your notes. The weirdest one is this, right? Tetra. Tetra is 4. Okay, all the other ones kind of make sense, right? Mono, di, tri, okay, shape names and stuff like that. 4 is different. Alright, so you might be asking yourself this. Why do we need to use prefixes? Well, the answer is this, right? because the same elements can form many different combinations when we talk about covalent bonds. Because we're not dealing with charges, we're dealing with shared electrons. So here's one right here. CO, right? Carbon and oxygen can form carbon monoxide with one oxygen, or we can form carbon dioxide with two oxygens. So we need to tell the difference, right? So we use those prefixes. Another example is this, nitrogen dioxide, right? We could also have this. We could also have dinitrogen trioxide. Okay? Now one thing I want you to notice is this, is there's no mono on the first element. So when there's only one of the first element, we don't use mono. All right? However, if there's one of the second element, we need to use mono. That's just kind of a general rule. Okay, something we'll have to work on. So let's try naming these two, right? We have OF2. So that means we have this, right? We have O is oxygen, so we say oxygen. And then we say this, F2. So that is di for 2 fluoride. Don't forget to change the end into IDE. Second one here, P2O5, right? I mentioned this one before. So here we have this, right? We have diphosphorus. Then 5 is pent, so we say pentoxide. There we go. So that's how we name covalent compounds. So to sum this up, here's the deal. After we do some practice, we'll be working on this in class. When you come back to class on Wednesday or Thursday, we're working on telling the difference between ionic and covalent compounds, right? We're going to name binary covalent compounds, right, using prefixes. And we should be able to explain differences between ionic and covalent compounds. All right, that is the goal. Well, thanks for tuning in, you guys, and I will see you in class. Bye-bye.